Good afternoon, everyone. We will start in 2 minutes. Okay. Good afternoon, everyone. Welcome to Natural Farming Solutions, a paradigm shift. First, my name is Kian Bauka from Camden Agriculture, and I'll be your moderator for today. I'm glad to welcome all our guests from PHILSAN and our industry partners for spending your time with us. In partnership with Natural Remedies, India's #1 veterinary herbal company, we would like to showcase the potential of natural farming solutions in supporting the needs of our animals. With more than 100 of studies globally, Natural Remedies were able to combine India's most famous Ayurveda with today's scientific advances to lead us to a greener livestock production. It is in line with Camden's vision of sustainability. Before I introduce our speaker, may I remind everyone that the Q&A portion will be at the end of the program, but you may post your inquiries on the chat box during the webinar. Now, I would like to welcome our speaker, Dr. Prashanth D Souza. He is the General Manager of Formulation and Development of Natural Remedies, and is a professor with more than 50 publications. With his 30 years of experience in the field of phytomedicine for animal health, he will present to us the natural farming solutions, a paradigm shift. Again, let us all welcome Dr. Prashanth D Souza.
Sorry for a little lag. Welcome you all. Am I audible?
Yes, Dr. Prashanth.
A warm welcome to all of you. Welcome to the webinar on natural farming solutions, a paradigm shift. I will take you through this brief presentation. Thank you for your cooperation. So the agenda for today is we will walk you through the journey, from the traditional livestock farming to the evolution of phytogenics and how we have the modern day standardized botanical powder to meet the challenges of farming, animal farming. And in the end, we will have a brief question and answer session where we would like to answer some of the key questions that you may have. So if you see, earlier, in the olden days, in the early part of the evolution, like the source of food, the hunter-gatherer existence it settled to the animal farming approximately 4,000 to 6,000 years ago. The key mechanism of, let's say, animal protein would be hunting or gathering, hunting of animals or gathering of insects, things like that. Then the human race discovered that, there could be an organized way of growing the chicken, swine, cattle farming for milk, meat, and eggs. Right? When this was done, the productivity was low, local trade was encouraged. This was mostly happening in the backyard, in an unorganized manner. With this, the evolution of livestock disease also started in a small way. Now, the solutions, of course, the solutions back then were of natural origin, some homemade solutions. Then, as the farming process improved, it gave rise to the synthetic solution. Now we are back to the basics. We are looking for the natural solutions because of some distinct advantages with the natural products. So, what are the challenges that we have encountered? Growing demand over the last 250 years due to increased population and spending capacity. There's a big demand for, the animal farming, right? More efficient breeds of chicken, swine, and cattle are being developed through breeding. So there is a high productivity with lower feed intake has been the mainstay for 60 years. So we want our farm animals to produce maximum by eating less. That means we need to have a better feed conversion ratio. So higher productivity due to animal breeding and genetic modification led to increased pressure on animals to produce more from less. So this gave rise to certain managemental practices like beak trimming in chicks, tail docking in piglets, housing and overpopulation, overcrowding stress, the emission of methane gases by, let's say, the ruminants gave rise to global warming, climate change, rising feed costs, increased malnutrition and hunger. Use of chemical products, the use of antibiotic growth promoters that led to unregulated usage, led to the resistance to antibiotics. Toxicity issues, the residues left in the meat led to the toxicity issues, and unfortunately, side effects and environmentally unsustainable solutions. So these were, as we traveled in the journey of animal farming, we encountered all this. So natural solutions are certainly a viable and a very interesting solutions to combat modern challenges. Once again, this space also has evolved over the years. So just to take you through this evolution, if you take the age of traditional medicine, in India we have the Ayurvedic system of medicine, just like the Chinese have the Chinese system, and I'm sure the Philippines also, in Philippines you have your own traditional system of medicine. So in India we have the Ayurveda, the Indian school of medicine is one of the leading systems of traditional medicine. It's about 5,000 years old. It basically looks at correcting the imbalances in an organism. That's the mainstay of the Ayurveda, where we look at the organism in a holistic way, not just look at only a particular system. So, encompassing this philosophy of a holistic approach, we in Ayurveda, the medicinal plants are used, practices, exercise practices like yoga, promoting philosophy which talks about good thoughts for both physical and mental health. And also a section of Ayurveda looks at the food that we eat. What it believes is a healthy diet would prevent most of the disorders. And so food is in a way a kind of prophylactic medicine. So basically Ayurveda means the science of life. So over the years, the evolution of knowledge has happened. So with the traditional knowledge transfer from one generation to the Vaidyas. Then later, there has been a marriage between the traditional medicine and the modern science. So the modern science, especially in India, if you see, we combine the glory of traditional medicine with the power of modern science. So we have the power of chemistry, modern chemistry, to understand the phytocompounds in plants, then applying current technologies in biology to understand how the plants work. We also apply the skills in agronomy to grow these medicinal plants. Then we use the latest in the quality control to check these medicinal plants. And we have formulation technologies to arrive at the best formulation, which gives the best impact in terms of stability and efficacy. And of course, the production process, which create the safe and effective preparations, formulations. So this has given rise to the phytomedicine, which has a scientific backing. So the age of phytomedicine, you are all aware, it started with, if you say about 100 years back, the traditional medicine, a refined form of traditional medicine like extraction of morphine from poppy seed as an analgesic or quinine to treat malaria. These are some of the leading examples. So the modern medicine actually has its root in the plant world. So then you have seen some very classical examples of this evolution. You may be very much aware of vincristine and vinblastine, the alkaloids, which have been used in cancer medicine. Similarly, Taxol, which is used once again for breast cancer, and artemisinin, a latest molecule which received the Nobel Prize in 2015, which is an anti-malarial drug. So from the simple practices of traditional medicine, the phytomedicine has evolved to isolate compounds and to apply this in modern medicine as well. So these examples that you see in the slides are some of the remarkable ones. They say 50% of the modern drugs have some root in natural products chemistry. So this gave rise to an array of pharmacopoeia and compendiums like the British Herbal Pharmacopoeia, which played a very significant role in the practice of medicine, Herbal Medicines Compendium, then the German Commission monographs, and the Thai Herbal. So of course, now the main focus is on modern medicine, but these were very active in the early journey of modern medicine. I'm sure in other systems, the traditional medicine also played a significant role. For instance, in Vietnam, we learned that research on traditional medicine in Vietnamese does not require decoctions to be used, complicated decoctions to be like the way in Chinese medicine. So each system of medicine has its own philosophy and the way to address the health needs. So, for example, in Philippines, you have example like Vitex Nigudu. It is widely accepted to treat multiple ailments. So each country, through the course of trial and error, has discovered medicinal plants to address health issues. And in India, our government has created a regulatory body called Ayush, AYUSH, which has done a very phenomenal job in the area of Ayurveda, and we have these compendia like the Pharmacopoeia of India is published, the Ayurvedic Formulary, which is a storehouse of all the classical Ayurvedic preparations. These are published in the Ayurvedic Formulary of India. Similarly, we have many other important publications with reference to the Indian medicinal plants by various Indian agencies. Now, if you look at the chemical era, the improvements in organic chemistry and combinational chemistry gave rise to the modern drugs. Several chemical classes. Of course, they have been life-saving, but there also has been the challenge of toxicity, especially in the area of animal health. For instance, when you use antibiotics, the challenges, the residues that are left in the meat or in the milk or in the eggs can pose the challenge of antibiotic resistance. So the negative effects of some of the chemical drugs and the chemical revolution, I'm not discounting the positive effects of the chemical drugs. They have played a role, but still there is a big chunk of the negative challenges. So that gave rise to a renewed interest in the phytogenics. So from the traditional knowledge, it gives rise to scientific contributions with quality upgradations. So it gives rise to two broad areas. One is the phytomedicine for human beings and the phytogenics for animals. Now, if you see, the herbal supplement market is a large industry globally, and these herbal supplements are used to prevent some of the long-term health problems in human beings. Similarly, in animals, we have the phytogenics, which are used to improve performance or address some health issues in animals. And this is very rapidly growing area of animal health. So phytogenics, what are phytogenics? Phytogenic compounds are defined as plant-derived natural bioactive compounds with positive effects on animal growth and health. So you are looking at additives which can promote the performance, and also we look at the health condition of the animal. So these phytogenics, the modern ones, are formulated using modern scientific methodologies. So you have a spectrum of phytogenics. In the modern day, you have a spectrum of phytogenics. You could be using the whole herb. You just take the plant, dry it up, and you can use the whole herb like a dried powder leaf, or you can use dried root powder or the whole plant powder. You could be extracting, you could be taking a decoction of the plant material, that would be the extract, or you could be extracting the oleoresins from a plant, which is something like a plant, like a spice, for instance. Let's say curcuma, or let's say clove. You can extract the oleoresin, or you could have an essential oil extracted from a plant. For instance, basil oil could be one of the essential oil. Or you could even go purifying a particular active compound for developing a phytogenic. So in the market, you will find a spectrum of these products. Okay. Now, I'd like to take you through the biological actions of phytogenics, a brief snapshot of the biological effects. It is often postulated that phytogenic feed additives are antimicrobial, but phytogenic compounds have been investigated extensively as antibiotic alternatives. They have a wide spectrum of effects. Of course, the plants have an antimicrobial effect. If you look at the gut function, they could have an anti-inflammatory effect. They are known to improve or augment digestibility by stimulating endogenous enzyme secretion like the pancreatic secretions, which are involved in digestion, like, for example, pancreatic amylase, pancreatic lipase. They have been known to have positive impact on the intestine development, the intestinal morphology, villi morphology, for instance, stabilization of the microflora. A good number of herbs have been known to have a positive impact on the microflora, because the microflora plays a key role in the gut function of monogastrics as well as ruminants. Plant material, the phytogenics have been known to have a positive impact on feed intake, sensorial effects. The palatability of feed can be modulated with especially essential oils and plant extracts. They are known to have antioxidative effect. The farm animals experience a lot of stress. In the process, they can have oxidative damage. So plant material phytogenics can be useful in mitigating the oxidative stress. Similarly, the immunomodulatory effects, with the productivity being given a focus, the modern day farm animals have a very high productivity quotient, but they suffer on immunity. So phytogenics several phytogenics have a very profound immunomodulatory effects, which is going to be very useful in augmenting the immunity of animals. Similarly, the antiquorum sensing is also one of the features that you can find. That is, the bacterial signaling between the bacteria can also be modulated by plant extracts. Now, let me take you through quickly what are whole, but I'll explain you the different types of phytogenics. The whole herb botanicals. So these are derived from the whole plant or parts of the plant. You know, whole herb botanicals doesn't mean you necessarily have to use the whole plant. It could be parts of the animal. You don't literally actually extract anything out of it. You take the whole material. Crude drug powders are common. Multiple herbs elicit multimodal action. So when you take, let's say, a leaf material, dry it up, reduce the moisture to less than 10%, powder it to about 60 mesh, that would be an example of a whole herb botanical, where the entirety of that leaf material, the chemistry of the leaf is retained there. You know, all the compounds found in that particular plant material are retained. You're not extracting anything out. That would qualify for a whole herb botanical. Whereas an extract and oleoresin would be a little different. You would be extracting a section of the plant material. Suppose, let's go to the leaf material. You may be using a solvent like a water and alcohol, and then you would be extracting something like taking a decoction of the plant material. These would be the extracts. Semi-solid extract composed of a resin in a solution is an essential oil obtained by evaporating the solvents used for the production. So you have examples of oleoresins like garlic oleoresin, ginger oleoresins, etc. Maintaining optimum stability is one of the challenges in these type of preparations because they are away from the natural protection that the plant material offers. Similarly, certain plant materials like especially the spices, they contain the essential oils, the aromatic oils. An essential oil is a concentrated hydrophobic liquid containing volatile compounds from plants. So you can do the hydrodistillation and obtain the essential oil, like the cinnamon oil, like the turmeric oil or the ginger oil, essential oil, etc. So once again, these essential oils have to be well protected, or they get oxidized and they lose their effect. Also, they can be lost during, pelletization, for instance, in the animal feed manufacturing. So, to take you through the different ways of generating phytogenics, if you take the fresh material, you'll have to dry the plant material, you fine grind it, and then you have a straight botanical powder. You can sell it as such, the dried plant material. This is one form of plant material you could be, just excuse me. Yeah, you could be having a straight botanical powder, that is a dried plant material, but whole botanical powder. You could be creating an extraction of the plant material. After the plant material is dried, you can extract it, coarse grind it, and then extract it with a solvent like water, alcohol, or maybe petroleum ether, etc. You could be having a oleoresin or a tincture or a water extract. A tincture is a extract using alcohol, for instance. Then you could use it in a liquid state, or you could dry it up and create a solid herbal extract. Or you could go about isolating the compounds in the particular extract and obtain a pure phytochemical. So you can see a spectrum of herbal products. I just missed this out. The essential oil is basically obtained by distillation of the plant material. You get an essential oil. And of course, all of them have to be standardized. The botanical powder which you get here, when you apply high quality standardization, it gives rise to standardized botanical powder. So from the plant material, you could have a variety of options. So that depends upon the strategy of the company dealing with the phytogenics. What are the key challenges related to phytogenics? One is, of course, the proof of efficacy. Not all products in the market have a high quality of proof. One has to apply the methods of modern science and generate a high quality proof. Then the plant materials are grown in nature, so they are vulnerable to pick up mold contamination. So you could have aflatoxins or contamination by pesticides. You could also have stability issues in the feed, like the way I explained to you about the essential oil. Capturing the essence of traditional knowledge itself is a challenge. Natural variability. You grow the plants and their quality can vary in terms of geography, the quality of soil, the climatic conditions, the plant metal can vary in its quality. So you need to have a check on all this to ensure batch to batch consistency. Similarly, the lack of scientific knowledge on how they work, the mode of action is also one of the challenges related to phytogenics. And with the growing demand on phytogenics, supply chain itself is a challenge. The continued supply of the bioresource is itself a challenge. So a company which is dealing with phytogenics needs to have a sound agronomical practices, has to have a sound supply chain, or else there would be challenges in terms of quality and appropriate supply to the market. Modern Ayurvedic phytogenics, what is needed? You need to control the natural variations. As I told you, the natural products can vary in their quality because of various variables. We need to control the quality. We need to control the safety, that's the contamination levels in the products, like the toxins, aflatoxins, pesticide, solvent residues, for instance. We need to be monitoring the efficacy of the product by using suitable chemical methods, looking for the chemical markers, HPLC fingerprinting, etc. We need to apply analytical methods to identify and quantify the traceability of phytogenic compounds in feeds. Once it is blended, we need to ensure there is an optimal level of the phytogenic additive to produce the biological effect. So we use an array of instrumentation like HPTLC, ICP-MS, HPTLC, and gas chromatography to control the quality of herbal products. Now I'd like to spend a few minutes on the standardized botanical products. Special focus on natural remedies, standardized botanical products, which we call as the NRSPP. So a formulation made of finely processed and blend of herbs that is inspired by Ayurvedic sciences, subject to stringent quality standards. So NRSPP is characterized by a high quality of identity where we know what plant material we are using, where we use macroscopic, microscopic, and chromatographic characterization. So we know what we exactly use. Bear in mind that it's not always easy. There is always a possibility of misidentity in the natural space. People may believe it's holy basil, but it could be something else. Mistaken identity, the plant material used could be wrong. So we need to have a proper method to ensure identity by using these techniques. And also, the natural NRSPP is characterized by a close monitoring of the undesirable substances like the heavy metals, the pesticide residues, the aflatoxins, and the residual solvents. So this would ensure that the products used are safe to consume. Also, we need to ensure on the phytochemicals compounds or the chemical analysis of the products, phytochemical analysis to ensure the efficacy of the product. Last but not the least, we need to look at the consistency, batch to batch consistency of the material, both in the form of the appearance of the material and the chemical constituents to ensure batch to batch consistency. And also we need to ensure that the material is thermostable. So if you look at the chemistry of the plant material, broadly a plant material has the primary metabolites, which includes the basic nutrients like the carbohydrates, protein, and fats. Then you have the secondary metabolites. The plant, as a part of its metabolism, produces metabolites like alkaloids, terpenoids, glycosides, polyphenols, lignans, saponins, etc., flavonoids. Secondary metabolites are contained in the central vacuole, which is held together by tonoplast. These, you can say, are byproducts of primary metabolism. They help the plant to defend itself against, let's say, the invaders, some of the, the invaders of plants like herbivores, for example, or it could be substances which are byproducts of a metabolism. But these secondary metabolites have biological effects which could be interesting in terms of animal farming. So as I told you, these secondary metabolites offer protection against herbivores. They could be also used against competition with another plant. So a plant produces certain chemicals which could be suppressing. This is called allelochemicals. For example, certain plants produce some compounds which suppress its neighboring plants. These are called allelochemicals. Or it could be protection from sunlight, for instance. There are certain compounds produced by plant which can protect the plant from the excess sunlight, etc. Or they could be produced in response to pesticide or aflatoxin challenge. So plants produce these secondary metabolites for their own protection, and these secondary metabolites in turn are pharmacologically, biologically active, which could be useful for producing definite biological effects in animals for certain productive outcome. So you can have alkaloids, phytosterols, polyphenols, terpenoids, organosulfur compounds, etc., like berberine, diastenin, tannins, etc., glyceric acid, etc. These are all the different types of phytocompounds which have a pronounced biological effect in animal systems. So the secondary metabolites in a plant are many. Just to give an example, a dried leaf can contain as many as 20,000 compounds, 20,000 secondary metabolites. You take any leaf, it could be in Philippines or it could be in India, or it could be a fruit, or it could be a root. It will contain not less than 20,000 compounds, at least 20,000 compounds. So they are polyvalent. What do you mean by polyvalent? There are multiple compounds influencing complex biological targets within the animal systems. So that gives rise to what we call as the multi-target effect. So you have plant materials having a polyvalent chemistry, that is with several compounds in them, and they in turn influence multiple targets in a biological system to give rise to complex effects. Of course, these effects result in phenotypes which are beneficial to us. So to understand these complex effects, that is complex plant chemistry and complex interaction with animal system, you need the power of modern science. You cannot use some simple biological methods to evaluate it, because plant material is complex and the biological system is complex, that is animal systems are complex. So to understand this complex interaction, we embrace what is called as the omics sciences, the science of genomics, metabolomics, and proteomics. Also, metagenomics can be employed to get a comprehensive view about how plant systems influence animal systems. I am proud to say that at Natural Remedies, we have made a humble beginning and we are applying these omic sciences. So the phytogenics is both, and the development of NRSPP is both a science and an art. So when we combine different ingredients in a plant, we apply techniques like an isobologram or what is called a Taguchi orthogonal array to come up with the best rationale for combining the herbs. We just don't mix them. Of course, the traditional medicine mix them with some kind of trial and error and traditional knowledge, but when we do NRSPP or standardized botanical powder, we employ the power of modern science, the mathematical models like the Taguchi orthogonal array or the isobologram, to come up with combinations which are very rational, which are synergistic and additive, not antagonistic. So when you combine, you can have additive combination, or antagonistic or a synergistic. We look at combinations which can give rise to additivity or synergy and not antagonism. So thereby, we look for a kind of potentiated products. So if you look at the NRSPP concept with crude herbs and essential oils, let me take you through a brief comparison for a better understanding. If you look at the level of standardization, NRSPP and essential oils both are standardized. Whereas just if you were to pick up crude powders, just to take the plant material and grind it into dry powder, that would not be standardized. You are never sure about the chemical constituency and then you will not be sure whether the results would be reproducible batch after batch. Uniformity of batches. Yes, as I told you, the NRSPP is a standardized botanical powder, so you can expect consistent result, consistent chemistry. Whereas you will not get that in a crude powder. Even in essential oil, you generally, from a good manufacturer, you can find a consistency in batches. Active ingredients are multifold or polyvalent in the case of NRSPP as well as in crude powders. But in the case of essential oils, they are generally limited to a few compounds. So you have a multi-target chemistry more pronounced in a NRSPP compared to an essential oil, especially the essential oil mixture with 2-3 compounds. When you make a product, you have a rather limited multi-target effect than compared to a NRSPP type of product. Stability. The natural uh, remedies SPP contains multiple compounds and they are encased in the natural matrix. For example, if you were to take the leaf, we don't do any further processing. It is in the natural matrix in the plant material, so their stability is generally better. Whereas in the case of crude powders, you are not standardized, you are never sure about the stability. And in the case of essential oil, once again, the stability is a question mark because they tend to get oxidized. In the case of crude powders, you may not be controlling the moisture level, so you are vulnerable to have a degradation. So stability is a question mark there. Whereas in the case of NRSPP, we tightly control the moisture, the water activity levels, and ensure the stability. The carrier, in the case of NRSPP, we don't had any external carriers like dextrose or calcium carbonate, etc. So it's a natural carrier. Whereas in the case of an essential oil, you would find generally some kind of carrier to convert the essential oil into a powder. If you were to take a standardized essential oil product, it would contain as much as 90% carrier. 10% or 5% is the only essential. The rest of it is a carrier. So in the case of crude but powders, generally natural, they don't contain carriers. Quite similar to the NRSP. As far as safety is concerned, we check our products for a variety of toxins and contaminants. So which are complying to USP or EFSA. So you are very sure about their safety. Whereas in the case of a crude powder, you are never sure because you don't check for that. In the case of essential oils, you may have a good safety profile. Some of them are known to cause a lot of allergic reactions. Cost of production is relatively low for NRSPP, very low for crude drug powders, and very high for essential oils. So generally, these essential oil products are very expensive. Hygroscopicity is very limited in the case of NRSPP, almost none. Similarly with crude drug powders, but you can expect this problem in essential oils. Batch to batch consistency is good in the case of essential oil and NRSPP, whereas low possibility in the case of crude powders. The quality of standardization is once again good, very good in the case of NRSPP and essential oils, low in the case of crude drug powders. The reactivity with other feed ingredients is low in the case of NRSPP and crude drug powders, but since the essential oils are isolated molecules, it is of a higher order. They tend to react with, for instance, acids, organic acids, which are used in the feed. Sustainability is once again very good in terms of NRSPP because of our agronomical practices and our farming practices. Whereas crude drug powders, you never know, they could be collected in the wild, so the sustainability is poor. Once again, in essential oil, the sustainability is a challenge. Cost of production is low to moderate in the case of NRSPP, low in the case of crude drug powders, and very high in the case of essential oils. This is in brief a kind of glimpse in terms of the comparison between the NRSPP, CDP, and essential oils. So, calling it a day, I've taken you through the evolution of the phytogenics from traditional knowledge to the modern day formulation, which are characterized by better quality, validation in terms of efficacy and safety, a known mechanism of action, and also commercial manufacturing practices. And NRSPP in particular are characterized by high quality due to a good quality of standardization and high-end science, application of the high-end science. Now, I'm very happy to take you to the launch of two of our products you have been waiting for. I'm very happy to introduce you to two new solutions to the Philippines market. So we would be launching two new products, the Phyto C and the Choline Plus. So there is more in store. We have, as I spoke to you briefly about the NRSPP, we would invite you for a virtual tour on our, to know more about our research and development facility, our manufacturing facility. Also, you may have many questions about NRSPP. So my colleague would send you a link where you could go through a virtual tour to know these things. So over to Dr. Kian for the further parts of the program.
Okay. Thank you very much, Dr. Prashanth. I hope you all enjoyed this very informative presentation. Now, Dr. Prashanth will answer some questions that were sent to us during the presentation. Our first question is from Mr. Rodel Cueno. Is the combination of these natural secondary metabolites of more than 10 compounds more effective or beneficial compared with single combinations of thymol, carbacril, and even cinnamaldehyde?
Yeah, this is because, as I told you, if you take any kind of health issues in farm animals, let's say gut disturbance, so there is not just one target that is involved. There is inflammation, there is a disturbance in the microflora, then there is a depressed immunity. So multiple targets, multiple cellular cascades are involved. So what the current science has seen is if you apply a multi-target approach with multiple compounds, like the way it is found in NRSPP, you are likely to have a much more pronounced effect than influencing just few targets. So if you have few phytocompounds like carvacol or thymol and not have a multi-target chemistry, you may have a better control, very sharp control on those compounds, but you fail to have a multi-target influence, which is nowadays found to have a very comprehensive effect. You have a very holistic effect and a more pronounced effect in terms of having the biological effects. So the polyvalent effects or the multi-target effects is one of the unique features of herbal products, especially a product which something like NRSPP, which is holistic to address the challenges of animals.
Thank
Over
you,
to you now.
Dr.
Yeah.
Prashant. I hope we were able to address Sir Rodel's question. Okay, so our next question is from Sid. Okay, so what test should be done to differentiate stability of phytogenic products?
What test should be done for? Sorry.
What test should be done to differentiate the stability of phytogenic products?
Stability. Okay.
Yes.
So we need to certainly check the stability. So one is at the time of development. So once we finalize a formula, a particular herbal phytogenic formula, we need to look for the physical stability. The color, odor, the smell has to remain consistent over the claimed shelf life. That's the phytochemical stability. Then we look for the chemical fingerprinting. So as I told you, a phytogenic product like a NRSPP is a multi-compound chemistry. So when you do a chromatographic graphic profile, either using thin layer chromatography or HPLC or any other suitable technique, you could have what is called as a fingerprint. So you can use the chemical fingerprint as a tool for ensuring stability over the claimed shelf life. Suppose we say the product is stable for 2 years, we need to show the chemical fingerprint is stable for 2 years. Then comes the extractive values, which are basically gross representations of the metabolite content. So they need to be monitored. Also, the microbiological stability or the claimed shelf life. We don't want the microbial load. There will be a small background load in any crude herb, not pathogenic. Their number should not increase. Last but not the least, the selected marker compounds that we may, for a particular product, let's say gallic acid in Phyto C, for example, should remain stable over the claimed shelf life. Also, when you blend it with the feed, the compounds have to be stable. So this is what characterizes the stability of plant material. So physical stability, physiochemical stability like the extractive values, microbiological stability, fingerprinting, and also the selected active compounds. All these different types of aspects have to be looked into the stability or the claimed shelf life of the product. Last but not the least, when you incorporate in a feed and prepare a pelleted feed, you need to do also the thermal stability. The product has to be stable for the pelleting conditions. Thank you.
All right. Thank you for your answer, Dr. Prashant. That's really scientific. Just to follow up, this is a question from Mr. Oliver Pisueña. Can a standard third-party laboratory validate the presence of active ingredients in the natural products you are presenting?
Sorry, can you speak a bit slowly? I'm sorry, I'm not able to get your accent, please. Sorry.
Can a standard third-party laboratory validate the presence of active components in the natural products we are presenting?
Sorry to make you repeat the question. I got it. So yes, see, we use the following techniques. Primarily, we use HPLC, high performance liquid chromatography, or thin layer chromatography, or we can say gas chromatography. These are some, and then some basic wet chemistry techniques, extraction or distillation techniques. So these are very much doable in a third party laboratory. So we can share the method of analysis, MOA, and in most cases, it will be possible for a third party lab to do it. For instance, Eurofins is able to analyze in choline plus the phosphatidyl choline content. So yes, to answer your questions, yes, a third party lab can analyze for checking the quality of our products. And we can assist such labs by providing the suitable method of analysis. And we are actually doing that for many customers. Hope it answers.
All right. This is one question again for from Miss Kathy. Your
Mhm.
botanical powders do not have carriers. Will it not affect the mixability of the products?
Mhm. Okay. So let me tell you why a carrier is added. When you extract a plant material, let's say with water or alcohol, or when you isolate a essential oil, the essential oil will be liquidy. It will be in liquid form. Or an extract will be like a paste. It will be like a jam. It will be like a sauce. So now you need to convert a sticky material or an oily material into a powder. So that's where you add a carrier. In the case of a botanical powder, you already have a background fiber material. So you just have to ensure proper grinding technology. We use one of the finest grinding technologies and ensure the particle uniform particle size and ensure the moisture levels are well within the limits, less than 10%, and ensure the uniform grinding. So you need to have high quality grinding technologies and sieving methods. Once you do that, the flow property can be ensured. So the carrier is not required. Carrier unnecessarily dilutes the product and adds to the cost. You don't need a carrier. You need a carrier only when you have a sticky material, you have an oily material. Only then you need a carrier to convert the oily material into a powder. So when you have an oil, for example, you want to add 10% oil, 90% is a carrier. The 90% converts the oil into a powder. But when you have a powder already with you, like a botanical powder, which is free flowing, you don't have a need to add a carrier, and it maintains good flow property as long as you take care of the proper grinding and sieving methods.
Thank you, Dr. Prashant. I think we can wrap up now. Thank you again for answering those
Thank you.
questions, Dr. Prashant, and for the great presentation. It was a pleasure to have you with us.
Thank you
So
so
to
much. Thank you.
conclude, it is indeed worth noting that the evolution of animal production should be holistic. And with the help of natural farming solutions, we will be able to cater not only the needs of our animals, but also the safety of the end consumers, all while upgrading the quality of production. On behalf of Camden and Natural Remedies, I would like to thank PHILSAN for this opportunity and also to thank you all for attending. We hope you have learned and enjoyed our program. Uh, for more inquiries, you may contact our Camden and Natural Remedies team anytime, and you may also send your feedback or questions through our feedback form that you can access with this link and QR code. Dr. Prashant, will you share our email addresses?
Yes, yes,
I mean, Dr. Prashant,
yes. Yeah.
can you share in your screen the our contact info and also the QR code? So you may send your questions with these email addresses. Also for the feedback, we are also sharing you the QR code for the feedback form.
So all questions, can be, addressed at omnicare.bd, natural remedy.
Omnicare.bd.
We will definitely get back. Thank you very much.
Sir, could you please just take the slide a bit forward? This is the next slide to access the QR code. Yeah, thank you.
Here's our feedback form. You can scan it with your phones. You can also send your questions, your further inquiries regarding natural remedy products to our feedback form.